So we're on day 2, characteristics of functions. So again, this is all going to be a review of what you already learned in units 2, 3, and 4. So let's see which of these characteristics you already know. Let's start here at the y-intercept. The y-intercept is where the graph crosses the y-axis. That is where x equals 0. I mean, if you think about it for a second, what we have is our graph here, and it's this piece, right? That's where we touch the y-axis. Sometimes they'll want it as an order pair, so it's always 0, comma y. But again, notice here, x equals 0. So the x-intercept is where the graph crosses the x-axis. That's where y equals 0. So we described it as the x-intercept in unit 2. But then whenever we talked about it in unit 3, the quadratics unit, we also described it as a root, as a 0, as a solution. So notice here, if we write this as an order pair, y equals 0. The y coordinate is 0. And I've taught a pre-calculus class where I would ask them to describe the x-intercept on question number 2. Then question 3, I would ask them to name the roots. Question 4, I would ask them to name the zeros. Question 5, I would ask them to name the solutions. And you should have seen the faces when the students realized that they wrote the same answer 4 different times. But that's because these 4 terms are synonymous. All right, the domain of a function, these are all of your possible x values or the inputs. Remember, domain deals with how far to the left do you go to how far to the right do you go. If the domain goes from negative infinity to infinity, this is how we write it in interval notation. This is how it's written as an inequality. It's described also as all real numbers, and it has a symbol with a heavy stem on the capital letter R. All right? The range of a set of numbers concerns all the possible y values. And when you look at the y values, it's how low does the graph go to how high does the graph go. And remember, brackets and parentheses are all there, depending on whether you touch the value or you don't. And that's y is less than or equal to some number, or y is greater than or equal to some number. The vertex deals with a quadratic function. Remember, when you've got a parabola, the vertex is here. It is the middle point of the parabola. We normally call it HK. It will be an order pair with an x coordinate and then a y coordinate. So again, we look at that as HK. This is also where your max or your min occurs on a parabola. It's a minimum value here because it opens up. Had the parabola opened down, the vertex would be the maximum point. All right, the axis of symmetry. I'm just going to draw it here. It's a dashed line, remember, on which the parabola reflects onto itself, or it folds onto itself. It is the line that divides the 2 images. It is x equals whatever the number is. So for this problem here, the axis of symmetry would be x equals h. And please remember, it's a line. So I need an equation there, not just some x coordinate. Then we use the term extrema. Those are your extreme values. It will be a maximum or a minimum. The minimum, remember, is the lowest point on a graph. And then the maximum is the highest point on a graph. We use this mainly for quadratic functions. Okay, so the lowest point on a graph is when the parabola opens up. And then the highest point on a graph is when the parabola opens down. Now, when I ask for the maximum or minimum value, that is the y coordinate. Okay, so this occurs at whatever the x coordinate is. Okay, and it's y equals some number, and it's going to be the k coordinate, out of hk. When we look at intervals of increase or decrease, when we're looking for where the graph increases, that's where the graph goes up. That's where we have a positive slope or a positive rate of change. Okay? We'll have a decrease when the graph goes down, and that's where we'll have a negative slope or rate of change. And then sometimes the graph is constant. That's where the graph is horizontal. And remember, that is a zero slope or rate of change. Think about it. If a graph is just like this, there is no change on it. Whereas increasing goes that way, and then decreasing obviously would go that way. So remember, these are your intervals on x's. So you are naming the x coordinates where the graph increases or decreases or stays constant. Okay? Please do not confuse that with positive or negative intervals. So when a graph is positive, we are above the x-axis, right? Because all of your y coordinates are positive. And it's negative when we're below the x-axis because all of your y coordinates are negative. And again, when we give the intervals, we discuss them in terms of x. All right, the end behavior. That is where the graph goes to the left and to the right. So it says as x increases. What we're saying here is as x goes to infinity, I want to know, where does y go? And as x decreases, as x goes to negative infinity, where does y go? That's really what we're asking. So that's how you see it, okay? So as x goes to negative infinity, the graph is moving left. As x goes to positive infinity, the graph is moving right. And remember, rate of change is the change in y over the change in x, the rise over the run. If you are confused with rise over run and you're very, very comfortable with the slope formula, by all means, please use it. Okay, so these are all of our definitions, these are the definitions of the characteristics from units 2, 3, and 4. Unit 2 concerned linear functions. Unit 3 concerned quadratic functions. And remember, unit 4 was exponential. So let's actually revisit, also known as review, some of these, okay? So let's look here. This is a linear function. And remember, in a linear function, the domain is always negative infinity to positive infinity. So these are all real numbers. And then the range, this goes down forever and it goes up forever. So again, our range is this. Any number can be an x coordinate. Any number can be a y coordinate. Our x-intercept. Okay, the x-intercept, remember, it's where we touch the x-axis. It's where y equals 0. So that is here. So our x-intercept is -4. Now, I would describe it just as -4. But on the previous notes, the notation actually had it as an order pair. So we should also write this in here. So our order pair is -4, 0. X is -4 when y equals 0. That happens there. Okay. Our y-intercept, remember, is on the y-axis, and that's where x equals 0. So that's here. So my y-intercept is 2. And that's what I ask you whenever we're graphing. I'll ask you what the y-intercept is, and you tell me 2. You don't tell me 0, 2, but sometimes it may show up that way on a multiple choice test. So I'm going to make sure you're comfortable using either just naming the y-intercept itself or giving me the coordinates for the y-intercept. Okay, the 0, remember, is another term for x-intercept. Again, it's where y equals 0. So that happens at -4. Again, the coordinates for the 0 are -4, 0. The interval of constant. Where does this graph have a flat line? Where does it have a slope of 0? It doesn't. So it has no interval where it's constant. Interval of increase. Where does this graph have a positive slope? It kind of has a positive slope everywhere, Robadeer. Okay, so how do we describe everywhere in algebra? We describe it as the interval from -infinity to +infinity. And where does this graph have an interval of decrease? It doesn't. So again, there is no interval on this graph where we have a negative rate of change. A maximum and a minimum, there is none. There is no highest point, because once you think you found the greatest y coordinate of 4, well, this says move on. I could find the greatest the y coordinate is 5. You would say 6, I would say 7, and on and on and on. So there's no maximum. Likewise, there is no minimum. Okay. Now we want to look and see where this graph is positive. Well, this graph is positive from here up. Okay, so the graph is positive. Yeah, let's use this. So this graph is positive here. So it looks like where x is -4 to forever. So our graph is positive from the interval 4 to infinity. Or you could say where x is greater than or equal to -4. Think about it. From here, all of my y coordinates are positive, okay? I'll even make that notation. This is where these are positive y coordinates, okay? So of course, if I'm going to ask you where the graph is positive, I'm going to ask you where the graph is negative. And let's see where that occurs. Well, that occurs here. Okay, so from here down, all of my y coordinates are negative. So that happens from -infinity to -4. Robadeer, this is going to take me a minute. That's okay. Just think of it this way. Oh, I forgot. I should have these exclusive. My bad. Because usually you don't touch an interval, but that's okay. A lot of math teachers agree back and forth on the two. All right, let's look at end behavior. As x approaches -infinity. In other words, as the graph goes left, what's happening to the y coordinate? Well, this is actually going to go down. So this will approach -infinity. And as x goes to the right, what's happening? Well, the y coordinate is going up, which means it's going up to +infinity. All right. So I looked at this and I paused for a second there because I thought you have to give me an interval where there's a rate of change. No, I don't. It's a linear function. So it's going to have the same rate of change throughout. So let me find a rate of change. Okay, so I'm going to go from this point, or I'll go from this point on the graph to this point. So we go up 1, and to the right 2. So my rise over my run is 1/2. And if you need to see that as order pairs, well, I chose the order pair 2, 3, and the order pair 4, 4. So the slope formula tells me to take 4 minus 3 divided by 4 minus 2, which is 1/2. And yes, I should get the same answer on both. Different method, same answer. And so we know this is a linear graph. And let's review what we talked about from day 1 yesterday. How would I write that equation? Well, in a linear equation, it looks like this. For this problem, my slope is 1/2, and my y-intercept is 2. So this is what that equation looks like. So there's everything you need to know about the graph of a linear function and the equation of this particular linear function. So now let's move on to the quadratic function. In this quadratic function, the domain is always the same. We're going to go from negative infinity to positive infinity because it's a quadratic. The range, however, let's see what my lowest y coordinate is. My lowest y coordinate is -1. So we will go from -1 to infinity. Y is greater than or equal to -1. The x-intercept is where we touch the x-axis. That happens at 1 and 3. So we should consider the order pairs 1, 0, and 3, 0. Because remember, this is where y equals 0. And then let's look at our y-intercept. Our y-intercept is here, where where x equals 0. So my y-intercept is 3. So the order pair is 0, 3. What are my zeros? Well, my zeros are the same as this. So my zeros are 1 and 3. All right. My interval of constant. Where do I have a 0 slope? I don't. Okay. Interval of decrease. Where is this graph going uphill? Right here. So it's going from 2 to infinity. And then where is this graph going? Downhill? Well, it's going downhill here. So from negative infinity to 2. Is there a maximum value? No. Is there a minimum value? Yes, it's the y coordinate. Where are we positive? Well, we're positive here. So it looks like here and here. So we're positive from negative infinity to x equals 1, and then we go positive again from 3 to infinity. Where are we negative? We're negative here between 1 and 3. All right. As x approaches negative infinity, as x goes to the left, we're going up, which means we go to positive infinity. And as x goes right, we are going up also. And our rate of change from when x equals 1 to x equals 4, well, that's from here to here. So we go up 3 and to the right 3. So our rise over our run, 3 divided by 3 is 1. If I wanted to look at order pairs, I've got the order pair 1, 0 and 4, 3. So 3 minus 0 divided by 4 minus 1, is 3 divided by 3, which is 1. So I get the same answer either way. So there's everything you need to know about a quadratic formula, and we're good. Oh, let's look at the exponential function here. My domain, remember, of an exponential is always negative infinity to positive infinity. Okay, my range, what are my y coordinates? Well, in our basic exponential function, we're going to go from 0 to infinity. So it's where y is greater than 0. The x-intercept, do we ever touch the x-axis? No, because we never touch 0. So there is no x-intercept. Is there a y-intercept? Yeah, the y-intercept is right there. Where are we increasing? Well, this thing is increasing everywhere. So we're going to go from negative infinity to positive infinity. Where are we decreasing? Nowhere. Do we have a maximum value? Is there a definite highest number? No. Is there a minimum value? Is there a definite smallest number? No. Where are we positive? We're positive everywhere because the whole thing is increasing all the way through. Where are we negative? Nowhere, because we're always above 0. What is my asymptote? Well, for any function, the asymptote is y equals 0. And behavior. As x goes left, what happens to the y coordinate? It levels out at 0. And as x goes to positive infinity, or to the right, we're going to go on forever. And then our rate of change from where x equals 0 to x equals 1, well, we go up 3 and to the right. Nope. We go up 4. 1, 2, 3, 4, and to the right 1. So my rise over my run is 4 over 1. And then when I look at my order pairs, I've got 0, 2, and then I've got the order pair 2, 6. So 6 minus 2 divided by 2 minus 0 is 4 divided by 2. Whoa, this is 1, 6. My bad. 1 minus 0 is 1, and so 4 divided by 1, good grief, is 4. All right, so there's everything that we have talked about with exponential functions, quadratic functions, and linear functions.